Good morning everybody. So today our topic is kinetic theory of gases and thermodynamics. Okay, so like individually if you take these chapters we won't get much questions, but if you combining both chapters there will be lot of questions which we can practice. Okay, that's why we have combined these two chapters. First one is kinetic theory of gases. In that, let's see what we have to study. In kinetic theory of gases we have kinetic theory, like there are some postulates. Okay, kinetic theory is some postulates of how the gas molecules behave. For example, like if in physics we know, like we are studying the motion of objects, okay, how their behavior is. So when a ball is moving, like multiple balls are there, what do? Like we have to get a theory for combining all these things. So for studying energy and all, we will start using integration. But for gases it is like infinite number of molecules. Okay, like if you consider this room itself, there are so many molecules, we won't be able to physically calculate everything. So we have to introduce a new theory, that is kinetic theory. Then there is VRMS, V, that is root mean square velocity, most probable velocity and average speed, and degree of freedom, equipartition theorem. These are the topics included in kinetic theory of gases. Coming to thermodynamics, we have thermodynamic process, then first law, work done by gas, specific heat and efficiency of heat engine. Okay, so these are the topics that we are going to cover today. Coming to kinetic theory of gases, there are some postulates which we need to consider. Okay, so gases are mostly empty space, which means if you consider the volume of the container and volume of the gas molecule, you can see that one molecule will be like very small compared to the total volume of the container. So there are so many empty space when we are considering about gases. That is first one. Okay, second one, gases contain molecules which have random motion. Like all the molecules in gas are moving randomly. That is the second point. Third point, molecules have kinetic energy. Since they are in motion, they have velocity. If they have velocity, they have kinetic energy. The molecules act independently of each other and there are no forces between them. Even though we say van der Waals forces, molecules attract each other, in gases that van der Waals forces are very less. They are negligible, so we can neglect them. Then molecules strike the wall of the container and collision are perfectly elastic. So if you consider a molecule here, it will move randomly here and there, and sometimes it will hit the container walls also, right? So that collision is elastic collision. Okay, and due to that collision, pressure of gas is created because of the collision of gas molecules with the walls of container. Then exchange energy with the container. Okay, elastic collision means they exchange energy with the containers like walls, but walls are not moving, so its momentum will be conserved. So all those things we have to see. Then energy of the molecules depends on the temperature. That is another thing, energy of the molecule depends on the temperature. One more point is there, that is all gas molecules we consider as identical spheres. Okay, all the gas molecule we are assuming as identical, like one molecule will be identical to other and we consider them as spherical objects. Okay, spherical point masses. Is that clear for all? Like what are the assumptions we are taking while studying about kinetic theory? I mean studying the gases. Okay, coming to next, we have ideal gas law. Ideal gas law is PV equal to nRT. For so long you have been studying this, I hope you remember this. Okay, this is ideal gas equation, PV equal to nRT. In the previous slide I told you, when the gas molecules are colliding with the walls of container, what is created? Pressure due to gas is created. So we derived with such an assumption that collisions are making pressure and we derived a formula for pressure, that is this. As you know, for entrance we don't need the derivation. If you want the derivation, you can check the you can search for it, but it is not required. You only need this formula. Pressure of gases in a container is equal to 1 by 3 rho. Rho is density of gas, okay? Density of gas, and V average square, that is average speed, or here it is taken as RMS, okay? RMS velocities square. Here it is not average speed, here it is RMS velocity square. Is that clear? What is RMS velocity? We will come in next slide. But did you understand the equation here? Pressure equal to 1 by 3 rho V square. Okay. Coming to kinetic energy of gas molecules. Okay, pressure is we derived for a value for pressure. Then we have ideal gas equation also, and now we have to find kinetic energy of the gas. Kinetic energy equation will be half mv square, that we know. Okay, m can we write as density into volume. Okay, so density we have here, volume if we multiply we will get in this form. Okay, v square also we have here. Okay, so substitute, considering these three equations, we can write kinetic energy equal to 3 by 2 PV. P is pressure, V is volume. Here V is RMS velocity square. And since PV equal to nRT, we will again get another formula, that is kinetic energy equal to 3 by 2 nRT. Is there any doubt in that? Okay, so that's why, see, kinetic energy now we are directly getting proportional to temperature. That's how they said that energy of the molecules depends on temperature. Clear? And this kinetic energy is also called as internal energy. Okay, U. Internal energy, U, is what this kinetic energy is. U plus kinetic energy plus potential energy. But as we told, there are no intermolecular forces between them. So potential energy will be very negligible. So we can say that kinetic energy is internal energy. Is that clear for all? Okay, so moving on, we have a relation between Boltzmann constant and gas constant. Okay, R is our gas constant from our PV equal to nRT equation. Okay, and K is Boltzmann constant. Okay, K is Boltzmann constant. And N is Avogadro number. Okay, so we have a relation that R equal to K into Na. So we can convert the equations with R into equations with K if you are considering one molecule. If you are considering the whole gas, we will use R in the equation. If you are considering for one molecule, you will consider K in the equation. Okay, so VRMS has a formula that is root 3 RT by M naught. Okay, root 3, this is gas constant, T is temperature in Kelvin. So here whenever we are considering delta T, we don't have to convert Celsius to Kelvin. Okay, delta T we can consider degree Celsius or Kelvin because the value will be same. But if we are taking just T, ratio of T, all those, then we have to use Kelvin only. Okay, temperature in Kelvin we have to use in other formulas. So root 3 RT by M naught can be written as root 3 KT by small m. Okay, in this small, like here m naught is like molecular mass, here m naught is total mass of the gas. Okay, here m naught molecular mass, here m is total mass of the gas. So this will be VRMS equation. This can be written as root 3 value is 1.72. You already know that. So 1.72 into KT by M. We can write in this form. Okay. Is there any doubt in this one? VRMS. And what is VRMS is, like since I told you, like gas molecules are moving randomly. If one particle is moving in this direction, another particle may be moving in opposite direction with same velocity. So if you take average velocity, it will be 0. Okay, for any gas like container, if you see, and if you find the average velocity in that container, it will be 0 because of random motion. Okay, so since average velocity is 0, we have to find some like some way to get like what will be the mean velocity of the objects, right? That's how we are finding VRMS. First, what we are doing is VRMS is equal to, we will square individual velocities. Okay, when we square, all the velocities become positive. Okay, then we find the mean. Okay, Vn square. Then we find the average of that. Then we will find square root of it. This is VRMS. Root of mean of square. Squaring, then finding mean, then finding square root. This is how we are finding VRMS. And we don't have to individually find the value. We can use the direct formula here. Is there any doubt? Okay, we will move on. Next is most probable velocity. Okay, since all molecules are having random motion, so they have random velocities also. All of them don't have the same velocity. It can go from, it will not be 0, from like just above 0, it can go from to a maximum value and it can change. Okay, so if you are plotting number of particle versus velocity, okay, you will get some value like this. Okay, so at lower velocity few number of particles are there, then at some maximum number of particles are having one particular velocity. That velocity is called as most probable velocity, and this is the equation for that. Vmp equal to root 2 kt by m. Okay, here it, like even though it is written capital M, it is small m which we used before total mass. Okay, this we can write as root 2 1.414 into root kt by m. Like this we can write. Why we have to write like this? Because this we can get from VRMS. Okay, so this can be written as 1.414 VRMS divided by 1.72. We can calculate most probable velocity. If you know RMS velocity, from this equation you can calculate most probable velocity. Similarly, this one, this is average speed. Okay, MP and RMS are velocities. This average we are considering speed. So average velocity 0, average speed not 0. Average speed value will be equal to root 8 RT by pi m. Okay, again we can convert it to in terms of k, that will be root 8 kt by pi small m. Again root 8 by pi we can separate and you will get approximately 1.59 into root kt by m. Okay. Is there any doubt regarding this? MP velocity repeat. Okay. Most probable velocity means our particles or different particles have different velocities. So if we are grouping, like this many particles have this velocity, this many particles have this velocity, like this, if you are saying, there will be like maximum number of particles. Okay, this is maximum number of particles have this velocity, that is called as most probable velocity. Okay, and formula will be root 2 kT by m, and root 2 if you take outside you will get 1.414 root kT by m, and since root kT by m we will get from Vrms, because Vrms equal to 1.72 root kT by m. So if you know Vrms, you can find Vmp using this formula. Okay. Similarly, this is average speed. Average velocity 0, average speed we can calculate. That formula will be root 8 kT by pi m. Okay. These are direct formulas only. You don't have any derivation for this. Okay. And here also root kT by m I can separate. So root 8 by pi, if I find, its value is around 1.59. So this one also you can find. Is it clear? Okay. So moving on to next topic. Next topic is degree of freedom. Okay. Degree of freedom, like it is a measure of how much independent variables an object have. For example, what is your freedom? Like how much freedom do you have? As you are like just passed out of 12th, you need both your parents' permission to do something. Okay, like that. So for a particle, if you are taking, how much independently it can move. So it can move in x direction, y direction, z direction. That is called as translational degree of freedom. Like if anything can move in x, y and z independent of each other, it is having 3 translational degree of freedom. Okay. And similarly, there is rotational degree of freedom. For example, if you take this pen, okay, it can rotate in this manner or this manner. Okay, so 2 rotational degree of freedom is there. Other than this, there is vibrational freedom, degree of freedom, but it will happen only in high temperature. Okay, so high temperature times this pen can like elongate and come back. So vibrational degree of freedom also present. Okay, so but it is not common for all molecules. There are monoatomic molecules, diatomic molecules, triatomic molecules, polyatomic. Okay, so depending on what type of molecule it is, degree of freedom will change. Considering our monoatomic molecule, it can move in x, y, z direction, that is there. But if it's rotate, we won't feel it, right? If a monoatomic molecule is rotating also, it is not rotating also, it won't affect us. So we will say that monoatomic molecule have 3 degree of freedom. Okay, monoatomic molecule have 3 degree of freedom, and we will represent degree of freedom with letter F. Okay, F is degree of freedom. This can be written as DOF also. Okay, DOF also means degree of freedom. First one, monoatomic molecule XYZ, 3 degree of freedom. Coming to diatomic molecule. Diatomic molecule, consider a pen. It can move in x direction, it can move in y direction, it can move in z direction. 3 translational degree of freedom is there. Now it can rotate also. I told you it can have 2 rotational mode of degree of freedom. So for diatomic molecules, 3 translation plus 2 rotation. Okay, so 5 degree of freedom will be there. For monoatomic molecule, F equal to 3. Diatomic molecule, F equal to 5. at normal temperatures. Okay. When we are coming to triatomic molecules, there are two types. Okay. Non-linear triatomic molecule and linear triatomic molecule. Linear triatomic molecule is like CO2. Okay, you know the like structure. It will be like this linear structure. It will have 3 translational degree of freedom, 2 rotational degree of freedom, and so 5 and 2 vibrational modes. So it is having linear triatomic molecule will have degree of freedom equal to 7. Okay, 3 translation, 2 rotation plus 2 vibration. Okay, now if you are considering non-linear triatomic molecule like H2O, its structure will be like this, right? Sorry. Its structure is like this, right? It is not linear, but it is triatomic. It is having 3 translation and 3 rotation. Okay, vibration we are not considering here. So it will have 6 degree of freedom. Is it clear? Monoatomic have 3 degree of freedom, diatomic have 5, triatomic, which is non-linear, have 6, and which is linear have 7. Okay, we only need those values for now.
What does N represent?
What does
N and R?
N and R, where? Okay, don't worry about this. This is not for you. Okay, that's why I explained with the like translation and rotation. Okay, this is not for you. Like we need only like translation motion, rotational motion, and vibration. If vibration is there, then we will consider. If it's not there, we won't consider, like that. Okay, did you understand that part, like translation, rotation, and vibration? Then we will move on. Okay, coming to equipartition theorem. Why are we studying degree of freedom is to find the energy of molecules. Okay, so energy of gases and molecules, if you want to find, you need equipartition theorem. From what it is saying is that energy of the molecule is equal to total energy is equal to F by 2 kT. Okay, so if you know degree of freedom, you can find energy. U is internal energy, as we already discussed. So here you can see, if we are taking monoatomic molecule, F equal to 3 and U will be equal to 3 by 2 kT. Okay, so to find energy, we are using equipartition theorem and degree of freedom. What equipartition theorem says is that there is half kT. Like if you want statement, this is the statement. Like for each and every degree of freedom, half kT energy is associated with it. Okay, this is for translation and rotation. Okay, when coming to vibration, like there is FKT for translation and rotation. In energy, if you are finding associated with it, you have to find F by 2 kT. Okay, now if you are finding for vibrational mode, U will be equal to FKT. Okay, so translation motion and rotation motion have F by 2 kT associated with it energy, and for vibrational motion have FKT associated with it. Okay, so let's say if you are talking about triatomic molecule. Okay, for triatomic molecule we have 3 translation, 3 rotation, and like we are 2 rotation, 2 rotation and 2 vibration. We are considering that. So its energy will be equal to 3 by 2 kT. This is from translation plus 2 by 2 kT. This is from rotation plus 2 by 2 kT. This is from vibration. Okay, is that clear? Sorry, here 2 by 2 won't come. Here it will be 2 kT. So if you know degree of freedom, you can find energy of the molecule. Is it clear? Or do you have any doubt regarding this? Okay, did not understand. Like degree of freedom and energy, they are directly related. If you know degree of freedom, you can find energy associated with it. If there is 3 translation freedom, okay, if like 3 F is equal to 3 and these 3 are from translation, then we can find that energy associated with translational degree of freedom is equal to 3 by 2 kT. Okay, like we are substituting F by 2. Now if it is rotation, let's say 3 are there, 3 modes of rotation, then we can say that F equal to 3 and U equal to 3 by 2 kT. If there is 3 rotational modes means. Now if there are 2 vibrational modes, okay, vibrational modes 2 are there, then we can say F equal to 2 and U will be equal to, won't be 2 by 2. For vibration it will be F kT. So it will be just 2 kT. And we will add all 3, you will get total energy. Now is it clear? Okay, moving on. Coming to thermodynamics, first we need to know about systems. Okay, there are 3 types of system we are dealing with. One is open system, another is closed system, then it is isolated system. Open system, we can exchange matter and we can exchange energy. So heat exchange also there, matter exchange also there, that is open system. Closed system, you can exchange heat but you cannot exchange matter. Okay, so that is closed system. Energy exchange can be there but no matter exchange will be there. Like first one you can consider as an open glass, second one like a closed bottle, third one you can neither exchange heat or energy or you can neither exchange matter. So it will be like a flask. Okay, energy also you cannot exchange and matter also you cannot exchange. So a closed flask if you take, it will be isolated system. Bottle, if you normal bottle you take closed one, it is closed system, and an open glass, it will be an open system. Is that clear about systems? I hope there is nothing to be having doubt in this, so we will move on. Coming to 0th law of thermodynamics, it is very easy. You won't get any numerical from this, maybe concept question you might get. What 0th law says is that, let's say there is a system A which is in equilibrium with B and A is also in equilibrium with C. Okay, that we know. A is in equilibrium with B, A is in equilibrium with C. Then 0th law states that in such a case B and C are in equilibrium. We can say for sure that B and C are in equilibrium. I think we saw a question from based on this in our mock test, last mock test. I think so. So A is in equilibrium with B, A is in equilibrium with C, and in such case B and C will be in equilibrium. But it doesn't say that A not in equilibrium with B, A not in equilibrium with C. It will not say anything about B and C. Okay. Now, like, what does an equilibrium of a system means? Equilibrium means that P, V and T, these three like elements like pressure, volume and temperature, their change will be constant there. Okay, equilibrium means pressure, volume, temperature, its state will be constant. That's how we can say one system is in equilibrium or not. Okay, so that is zeroth law. Moving on to next is first law of thermodynamics. What we will be doing like with most of the question is first law. Okay, so if you want, what it is saying is that, like, if you are giving Q amount of heat into the system, it will be used for internal energy change plus work done. Okay, it is written in a like different order, that's it. So here it means internal energy change can be caused by heat or work done. Here we are saying if you give heat to a system, it will cause two difference, that is internal energy change and work. Okay, so basically this will not tell us if the process is actually possible or not, or like heat is flowing from which direction to which direction. Nothing we can know from here, but like it will balance the energy. Okay, this is based on conservation of energy. Is it clear? This is first law of thermodynamics. This is the one we will be studying in detail, and basically we will be finding work done in each process. Any doubts? Okay, then let's see what type of processes are there. Okay, now if you are taking, if you are considering these processes, there is isobaric process, isochoric process, isothermal process, adiabatic process. Isobaric process means constant pressure, isochoric process means constant volume, isothermal process temperature is constant. Okay, T constant, and adiabatic process heat, like heat exchange is zero. So heat exchange zero, that is adiabatic process. I hope you got the difference. Isobar, bar is a unit for pressure, so pressure constant. Isochoric, that is constant volume. Isotherm, thermal, okay, so temperature constant. Adiabatic, energy exchange zero. Okay, so Q will be 0 here. Is there any doubt here? These all are based from our first law. We will come to that. Did you understand the difference in processes, like 4 different processes? Okay. Now let's see what is work done by gas. Okay, as you can see here, there is a piston and it is inside the container there is some gas present. Okay, that gas is at constant pressure P and it is having volume V initially. Then like what the gas did is, initially we have kept at that position, then gas expanded freely. Free expansion means with keeping pressure constant it is expanding. So what happened, it increased the volume by dV. Okay, so how do we find this work done? Work done equation equal to force into displacement. So we are assuming that like if gas has to expand with the constant pressure, we are saying that there will be an external force. It will apply just enough force to just move very small distance. Okay, so F dot dx is work done. Dx is like elongation, like how much it changed. Now force can be said to be like force by area is pressure. So force can be written as pressure into area. If you substitute that, pressure into area into dx. Area into dx will be change in volume. So we are getting the formula work done equal to P dV. Is that clear? We know this equation, F dot dx is work done. We just substitute that force equal to pressure into area. We will get formula that work done equal to P dV for gas. Okay. So moving on. We need to know about Cp and Cv, that is specific heat. Okay. Specific heat we are getting as like it is the amount of heat required to increase the temperature by 1 unit for 1 unit mass. Okay, 1 unit mass or 1 kg material we have, and we have to increase the temperature by 1 degree or 1 Kelvin. Then how much heat is required? That is our specific heat C. Now for gas, like other materials, solid materials or fluids, C value is single, like value of specific heat is 1 only. But for gases there are two types. One is if we are giving heat at constant pressure, and another one is if we are giving heat at constant volume. In two cases, two different specific heat are there. That if constant pressure it is called Cp, constant volume it is called Cv. These are directly related to our degree of freedom. If you know degree of freedom, you can find Cp and Cv. As you can see, Cp minus Cv equal to R. That formula is here. That is called as Mayer's law. Okay. Mayer's law is Cp minus Cv equal to R. One more is there, that is related to our adiabatic constant. Adiabatic constant is coming from the formula PV raised to gamma equal to constant. This is the law for adiabatic process. PV raised to gamma is constant. This gamma is called as adiabatic constant. That formula we will get by Cp by Cv. From here you can see that Cp equal to F by 2 plus 1 R, and Cv equal to F by 2 R. And from that you will also get that gamma is equal to 1 plus 2 by F. So this is the relation of Cp, Cv, gamma. Okay, I hope you guys are clear with this. Degree of freedom, if you know, you can find Cp, that is F by 2 plus 1 R, Cv is F by 2 R, Cp by Cv is gamma, so gamma equal to 1 plus 2 by F. And also if you want, Cp minus Cv is also equal to R, one more formula. Is there any doubt?
What does Cp and Cv indicates?
Cp is like we are giving the heat to the gas at constant pressure. Okay, and that in that case specific heat will be Cp. Okay, if you are giving the heat to gas at constant volume, specific heat will be Cv, like that. Specific heat means heat required to increase 1 degree, 1 unit of temperature for 1 unit of mass. Is that clear? Okay. So moving on. Like if we have mixture of gas, okay, Cp and Cv, like if you take a carbon dioxide will have one value of Cp, one value of Cv. But if we are mixing it with oxygen is having another value of Cp and Cv. How we can find the final value? Okay, so here you can see their molecular weight. Okay, total molecular weight of the mixture will be equal to N1 M1 plus N2 M2 divided by N1 plus M2. N1 is number of moles, N2 also number of moles of second gas. M1 molar masses of 1 and M2 molar mass of 2. Now if you want specific heat of that mixture of gas, just replace this M with Cv. You will get Cv of the mixture. If you replace it with Cp, you will get like Cp of the mixture. Similarly, if you want to find the adiabatic constant for the mixture, you have to find Cp of the mix by Cv of the mix. So you will get this formula. Okay. Similarly, let's say if you want to find like pressure or pressure of the mixture, then you can find N1 P1 plus N2 P2 by N1 plus N2. Okay, is that clear? Okay, moving on. First we will come to isochoric process, for which finding work done is very easy. Okay, if you want to find work done for isochoric process, which means a process happening at constant volume, graph will be like this, PV graph, because volume not changing, just pressure is changing. Okay, then we can say that work done equal to PdV, right? There is no change in volume, so work done will be 0. In constant volume processes, we can say that given heat will change internal energy, that's it, work done will be 0. And heat equation from Cp and Cv, we already have what? Q is equal to N Cv delta T. Okay, did you see those formulas there in CP/CV slide? Like heat energy we will always get by Ms delta T. M is mass of the object, S is specific heat of the object, and delta T is temperature change. And when coming to gases, we will change it by N, number of moles. From amount of mass, we will change it to number of moles into Cv into delta T. Okay, since it is constant volume, we are using Cv here. Okay, and since Q equal to delta U, we can say that delta U have a new formula. Change in internal energy you want to find. This is the formula for that, NCV delta T. Not just for like constant volume process, any process you can substitute this value. Change in internal energy equal to NCV delta T. Is that clear? Do you have any doubt here? Work done 0, which means from first law, Q equal to delta U, Q equal to NCV delta T from specific heat capacity equation. Then from that we will get delta U equal to NCV delta T. Can we move on? Okay. Next, coming to isobaric. This is this is also easy to find work done, because this, let's say this is final volume and this is initial volume. Since it is isobaric, it is happening at constant pressure P. Okay, so we can say that work done equal to that constant pressure into change in volume. This will be our work done. And since it is at constant pressure, Q we can say, right, NCP delta T. Okay, it is happening at constant pressure, right? So Q we can write as NCP delta T. And for delta U we already got the formula NCV delta T. Then work done equal to this. So from first law we can say that NCP delta T equal to NCV delta T plus P Vf minus Vi. Any doubts? This is for isobaric process, first law. Does anyone have doubt in this? Then can we move on to the next process? Okay. Next one is isothermal process. Here the derivation is getting like little bigger, but don't worry. We know that work done equal to P dV, right? If like P is also changing with V, which means isothermal process PV equal to nRT. T is constant, right? So if V is changing, P should also change. V increases, P should decrease to keep T constant. Okay, or PV equal to nRT or PV equal to a constant, we can say. Then can I say that P is equal to some constant by V? Okay, and this will be small amount of work done. For finding total work done, we need to find integral dW. So integral P dV we have to find from initial volume to final volume. Okay, and since we can substitute P equal to C by V, our integral will become integral Vi to Vf C by V dV. Okay, and what is this C? That is nRT. Let's keep it there. We will substitute it last. C into integral dV by V from Vi to Vf. What is the integral of 1 by V? Integral of 1 by V is ln V. So we will get this as C ln V from Vi to Vf. So further substitution we will get nRT ln Vf by Vi is equal to work done. Clear? Is there any doubt in this? And if you want to convert ln to log, you have to multiply with 2.303 nRT log log Vf by Vi. That will be work done in isothermal process. And coming to our first law, Q equal to delta U plus W, right? Since it is isothermal process, temperature is constant. In first slide we told you that like internal energy is proportional to temperature. Temperature change is not happening. So will internal energy change? No. So we can say that in isothermal process delta U is equal to 0. Okay, sorry, I think it is not visible. For isothermal process delta U is equal to 0. Okay, that we can substitute. Then we will get Q equal to W. In isothermal process, W we can find using this formula. Anyone have any doubt in this? See, you won't need the integration part. You will need this final two result, nRT ln Vf by Vi or 2.303, this one, and this relation Q equal to W. Okay.
Can you
Repeat
repeat?
what, like the whole derivation or last what I said?
Q equals to delta plus.
Okay, like temperature is not changing, right? We said that U is proportional to T. Temperature not changing, U will not change. So we are having delta U, change in U. So delta U will be 0. First law is Q equal to delta U plus W. Delta U 0 means Q will be equal to work done. Work done we found here. You need these two equations and this relation only, Q equal to W in isothermal process. Is that clear? Okay, so moving on to adiabatic process. Okay, in adiabatic process, as we said, our formula is PV raised to gamma equal to constant. Here we can substitute that P equal to constant by V to the power gamma. But here also our ideal gas equation is valid. Okay, here also we can say that PV equal to nRT. This is also valid in adiabatic case, but this is not constant. PV equal to not a constant because temperature is changing. PV raised to gamma will be a constant. Okay, so if here we are finding work done here, it will be from Vi to Vf, constant by V raised to gamma, then dV. Okay, this will be our integration. I am not going to do the integration because final result is given in the slide itself. W you can get. Okay, work done equal to T1 V1. We will do the integration, then substitute this. So we will get P1 V1 minus P2 V2 divided by gamma minus 1 as work done in adiabatic process. If pressure and volume not there, only temperature there, still you can find nRT into T2 minus T1 divided by gamma minus 1. So for work done, you have two equations for adiabatic process. Hello, I think our network was having some issue before. Is it okay now? Like I am audible and like screen is visible, right? Okay. So what I told was, like, we can integrate then substitute with this formula. So you will have two formula for work done in adiabatic process. P1 V1 minus P2 V2 by gamma minus 1, or NR into T1 minus T2, T2 minus T1, whatever, into gamma minus 1. So two values of work done. Now here in adiabatic work we said that Q will be 0. Heat exchange will be 0 in this case. So we can say that delta U will be equal to minus W. Negative of work done will be change in internal energy. Okay. For example, from this concept we can say that if you are shaking the like flask, there is water inside the flask, and if you are shaking it, means you are giving work to it, right? So what will happen, like the temperature of the water inside the like flask should increase. Okay, from this concept we can say that in an isolated system, if you are doing work, then temperature should increase. Same way, if you are in a closed room, like there is no heat exchange happening from outside, and you switch on the fan, means temperature should increase in the room. Okay, so there are some conceptual questions that might come from this. Is there any doubt? Like, am I audible to all? Okay, then we will move on to the next. Next is cyclic process. Cyclic process means it will start from one point of pressure and volume, then after the process it will come back to the same point. Pressure, volume, temperature will be same at the starting and the end. Such a process are called as cyclic process. Okay, so there are, if you want to find like work done in cyclic process, there are like only one way. So this is here, this process is happening in this direction. In this case, area inside the graph will be taken as work. Okay, this area will be considered as work done. And since it is in clockwise direction, work done will be positive. If the process is happening in anti-clockwise direction, work done will be negative. Okay, this is the concept of cyclic process. Area inside the graph will be like work done. If it is clockwise direction, positive, anti-clockwise direction, negative. Okay, in this also, like let's say random some graph is given, TV graph, something like this. If you are able to find this area, this is actually work done only. If you can find the area, that is also work done in that process. Okay. Is there any doubt regarding cyclic process? Area inside the graph will be work done. And do you know what is the difference of positive and negative work in chemistry and physics? Because whichever we take as positive is negative in chemistry. The reason is that in physics we are considering, like if I am doing work, we are doing work, it is negative because we don't want to do that. But if system is giving us work, then it is positive because we are getting the output. Okay, so if you are stirring the water, you are doing the work, so that is negative for us. And if like water is falling down and you are getting output as like potential energy, you are converting that to kinetic energy, then converting that to electrical energy, that water is doing the work, we are getting the result, work is positive. Okay, in chemistry it is just opposite. Okay, in physics we are seeing from our point of view, chemistry it is seeing from the point of view of the system. Okay, like system is getting the work positive, system is giving the work negative, like that. I hope you understood that concept. Okay. Now coming to heat engine. Heat engine is not an important topic, like it is deleted also, no, but I am just giving you an idea. If by chance any question is coming, like there are chances of coming out of syllabus question, you will be able to solve. Okay, heat engine is nothing but like there will be a source, there will be a sink. Okay, just imagine a normal bike. Okay, source is your engine, or like where the combustion is happening, fuel combustion happening, that is the source. Sink is the surrounding. Okay, atmosphere is the sink. And engine, the combustion is happening in engine, right? Like the work is done by the engine, that is our normal engine part. What are they doing? They are taking energy from the source. So fuel combustion, that heat energy the engine is taking, and it is doing some work for us, that like the vehicle is moving, and some of the energy is related into the atmosphere, right? Like through the silencer some like gas is getting released, so that is energy getting down to the sink. Now if you take that, like Q energy we are taking from the source, and Q as energy is released into the surrounding, and difference of this will be our work done, right? We are taking some energy, we are doing some work, rest of the energy is getting released. In this we are only going to learn about what is efficiency. Okay, here the condition is that source should be of high temperature and sink should be of low temperature. In normal heat engine, that temperature can vary, it should not be constant. But when it comes to Carnot engine, this is an ideal engine where temperature of the source TH and temperature of the sink TS will remain constant. Okay, for normal heat engine it is not constant, for Carnot engine it is ideal and it is constant. This relation, did you understand? Q heat we are taking, QS we are releasing, and the difference in that is converted as work. Okay, now coming to efficiency, can I change the slide? Is there any doubt in this? Okay, so coming to efficiency. Efficiency means, imagine you are paying someone to do some work. Okay, for you, if you are doing that, it will take 1 day, but if that person do in 3 days, like you are not getting the desired output, right? Same way here also, we are giving some fuel into the engine, but how much work we are getting, that ratio, that we will consider as efficiency. Okay, so efficiency is equal to output by input into 100. Okay, into 100 if it is in percentage. If it is in like ratio, this into 100 is not required. And what is our output? Work is our output. And what is our input? QH is our input. Into 100 if you want to convert to like percentage. Otherwise also it is called efficiency only. Now W we have the formula QH minus QS by QH. Okay, then we can get efficiency equal to 1 minus QS by QH equal to efficiency of heat engine. Okay, QS is energy released to the sink and QH is energy taken from the source. This will be efficiency of heat engine, normal. When it comes to Carnot engine, since temperature is constant, we can write that it will be 1 minus TH by TC. Actually it is TS by TH. Okay, don't get confused. Formula will be efficiency of Carnot equal to 1 minus temperature of the sink divided by temperature of source. Okay, is there any doubt in this? Even if problems are coming, it will be based on efficiency only. There will be no other question. Do you have any doubt? If not, we will move on to second law of thermodynamics. Okay. Now, second law of thermodynamics, don't worry at all, you will only get conceptual questions. Okay, there, you know, in your textbook there are multiple statements for second law. You don't have to worry about any of that. Second law just states that, we just said that QH minus QS equal to work done, right? It is just saying that without releasing any energy, we cannot completely convert whatever energy we are drawing from the engine, like source, we cannot completely convert into work. Some amount will be always wasted. That is one statement of second law. Another statement is that from lower potential to higher potential, naturally no process will happen. For example, from like if there is like AC in your room, okay, how the room is like cooler than the outside. AC is like doing work to take the temperature from inside and throwing outside. So without external work, from lower potential to higher potential, the work will not happen, like nothing will naturally happen. So these are the like second law statements, and from that the concept of entropy rises. Why? Because if something is restricting the like process to happen in one direction, what is that restriction? That restriction is entropy. Okay, entropy means disorderedness of the universe, measure of disorderedness. Universe always prefer disorderedness more than order. Okay, so natural process, everything will cause more disorderedness. Okay, nothing will be ever thinking like, okay, I want to get in order. So that will not happen naturally. Natural process will be for increasing the entropy, and change in entropy formula is delta Q by T, change in energy by temperature. This is like change in entropy. We cannot find exact value of entropy anywhere, we can only find change in entropy. Or if you want in like S final minus S initial way, this also you can get in 1 by T dq. Integral version formula also there. Is there any doubt regarding second law of thermodynamics or entropy? If not, we will move on to the problems P by Q. Okay, let's read, start solving. The container has two chambers of volume V1 equal to 2 liters, V2 equal to 3 liters, separated by partition made of thermal insulator. Chambers containing N1 equal to 5, N2 equal to 4 moles of ideal gas at pressure 1 atm and 2 atm. When the partition is removed, it attains equilibrium pressure of. As I told you, we have the formula. Pressure of the mixture will be equal to N1 P1 plus N2 P2 divided by N1 plus N2. Okay, and that's it. You can directly substitute, find the answer. See, they have simply given V1 and V2. We don't need that. It is just for confusing you. Okay. If somebody got the answer, please say. A. You are getting value A. Are you sure?
Option A.
Everybody is getting that value only. Okay. Then like I have marked the wrong one. Sorry. Then we will move to the next one. Okay. An oxygen cylinder of volume 30 liter has, volume is given, number of moles is given, 18.2 moles of oxygen. After some oxygen is withdrawn from the cylinder, pressure drops to 11 atmospheric pressure, 11 atm, at temperature 27 degrees Celsius. Mass of the oxygen withdrawn from the cylinder is nearly equal to. Okay, so initially some pressure was there, finally it became like 11 atm. So amount of oxygen that we took from initial thing, that is what we have to find. Okay, so let's see what are the things given in the question. Volume is given, initial volume, then number of moles is given, then final pressure is given, final temperature is given, and R value, gas constant value is given, molecular mass of oxygen given, then conversion of atm to Newton per meter square is given. What can we do to solve this? Okay, so we know that PV equal to nRT, that is ideal gas equation. Okay, final pressure is there, temperature is there. Can we find number of moles in the final state? We want to find number of moles in the final state. Is it like, is the Wi-Fi okay? Is it visible and audible? I hope in between the okay. So first let's convert 11 atm into like Newton per meter square. Okay, 1 atm is given as 1.01 into 10 to the power 5 Newton per meter. So 11 atm will be equal to 11 into 1.01 into 10 to the power 5 Newton per meter square. Okay, then V is given, R is given, T is given. Okay, so N equal to will be what? N equal to PV by RT. Use this converted value of pressure. Okay, substitute that. V is like volume 30 given, R is given, temperature 27, degree Celsius is given, you have to convert to Kelvin. Okay, so temperature will be equal to 300 Kelvin. All other values P just we converted, substitute and find this will be final number of moles. Then initial number of moles is given 18.2 minus this final number of moles will give you like number of moles that was taken from it. Okay, if you get number of moles, then like molecular mass is given, you can find number of moles is equal to like mass of the oxygen divided by 32 gram. Okay, so if you want to find mass of oxygen, M will be equal to N into 32 gram. Thus you will get the final answer. Okay, if you do this fast, we have time for one more question. And volume is given in liters, please convert that to meter cube. Okay, 1 liter is equal to 1 centimeter cube. Anyone got the answer? Here NF you will get as 14.5 moles. Substituting that here, you will get change in number of moles. Substitute that here again, you will get mass of oxygen. If someone solved and got the answer, please put in the chat box. Okay, final answer is 0.116 kg. I hope you solved it. This is the method using ideal gas equation and conversion between number of moles and mass. Moving like one more question we will do today, that is, two gases A and B are filled at the same pressure in separate cylinder, both are having same pressure and with movable piston of radius RA and RB. On supplying equal heat to both system at constant pressure, piston gas A and B are displaced by 16 cm and 9 cm respectively. If the change in internal energy is same, ratio RA by RB. Okay, so first let's talk about our first law equation, Q equal to delta U plus W. It is already said that equal amount of heat is provided. So Q1 equal to Q2. Q1 equal to Q2. Again it is said that internal energy change is same, which means delta U1 equal to delta U2. If these both are same, we can say that work done by first one equal to work done by second one. Okay, work done by first one, P1 delta V1 equal to P2 delta V2. Then first they are saying it is at same pressure, P1 equal to P2. So we can say delta V1 should be equal to delta V2. Volume, how can we find? Area into displacement. Displacement is given. Okay, area of first one into displacement of first one is 16 cm equal to area of second one into 9 cm. Area we can use pi r square area. From that you can substitute and find what is RA by RB. Anyone solving?
Option D, 3 by 4.
Yes, answer is option D, 3 by 4. Okay. Can we do one more question? Okay, next one. Equilibrium state of a thermodynamic system is described by. I think if this is concept question, we have time for 2. How do we describe equilibrium state? I told you in today's class itself. Which 3 quantities should be constant, or which 3 quantities we should take? Yes, answer is option D. We have to consider pressure, temperature, volume. These 3 quantities we are considering for finding the equilibrium of gas, okay, system. Moving to next question. According to law of equipartition energy, number of vibrational modes of a polyatomic gas constant gamma. We have to find number of vibrational modes. Cp and Cv are specific heat capacities of gas constant pressure and volume respectively. Like gamma is given to be Cp by Cv. You have to find a number of vibrational modes. Number of vibrational modes means I explained to you from equipartition theory, F like N1 number of freedom for translation, so 3 by 2 kBt, N2 for rotation, N2 by like kBt, like that you have to find 4 vibration. Okay, equipartition theorem states that U equal to F by 2 kT for rotation and translation. Then U will be equal to F kT for vibration. Now for polyatomic objects, okay, there are 3 rotational modes. Okay, only for diatomic 2 rotational modes, because rotation like this won't be considered for diatomic. For polyatomic, 3 translation, 3 rotation, vibrational modes we have to find. Okay, so total energy will be equal to 3 by 2 kT from translation plus 3 by 2 kT from rotation plus again FKT. F is number of degree of freedom of vibration from vibrational mode. So you will get as what? 3 plus F KT. Okay, 3 plus F KT you will get as internal energy. So this is the degree of freedom, right? 3 plus F. So you can say that Cp is equal to 3 plus F and Cv is equal to, Cv is equal to 3 plus F and Cp equal to 4 plus F. Okay. Now substitute that here, Cp by Cv equal to gamma, and you will get formula for gamma. Time is. Okay, answer is option C. I hope you can solve and find that answer. We will stop today's class here. Some more PYQs are in this slide. I will share it with you. Please solve that. And at 12 o'clock, please join for chemistry class. Thank you.